Hey everybody, nice to have you here. Well, in this tutorial series I'm going to teach you a bit about waves in processing and P5.js. And waves enable you to create complex animations and controlled motion behavior of objects in processing. So this is a fundamental feature or a fundamental skill if you want to dig deeper into generative design. We will talk about a few functions. Basically, this is a bit of math in the beginning, but don't worry, this is going to be pretty much fun. Once you understand how that stuff works, you will be able to apply this quickly to your sketches and you will really enjoy it. I'm pretty sure about that. So yeah, we are going to talk about the sine function, the cos function, radians, and the map function, which is, you know, everybody has to know the map function. It's like, you know, this is super important. And the tan function, which is a superpower. Cool. So let's get started. Well, if we're talking about waves in processing or P5.js, we don't mean those waves we see out there in the world, because those waves outside in the world are very complex. We are talking about very simple waves, right? In the beginning. So a wave in processing is basically something that has a value between -1 and 1. So we can use functions like the sine function to produce those values, right? So, and we have to pass a parameter into that function, which defines on which position of the wave the value is that should be returned from the function. Sounds quite complex, but it's super simple actually. So again, the sine function and the cosine function both only return values between -1 and 1. And we can use those values to multiplicate them, right? We can multiplicate them or map them to a different range to create a very controlled fluid behavior. So I've got a very simple sketch here. And what I want to do now, I just want to show you how to produce that kind of wave motion you've seen in this illustration before. So first of all, I have an ellipse in the middle of the sketch, right? So it's width divided by 2 and height divided by 2 is the position. And let's say it's well, something that has a diameter of 100 pixels. Well, I have to set the fill color to white and deactivate the stroke. And when I hit the run button now, I've got this beautiful round circle in the middle of the sketch window. Perfect. Great. Cool. So now let's put a wave into that, well, into the X position of this ellipse. To do so, we need to create a float, which I call wave here. And this float is created by a sine function, sin, which creates a sine wave. And well, into these parentheses of the sine function, we have to put an argument in. And this argument is defining on which position or on what position the wave should be. Let's put the frame count as a parameter into the sine function. And by the way, if I say argument or parameter, both are exactly the same. Sometimes I use parameter, sometimes I use the word argument. These are the things that we put into functions to tell them how to behave, okay? All right, so let's just put the frame count as a parameter into the sine function. And I hit the run button now. I won't see anything. I won't see any motion. Why? Well, because I don't do anything with the wave. You know, I don't use it in my sketch here. I'm just generating a variable that's called wave, but I don't do anything with it. And what I can do now here, I can put that wave into my X position of the of the ellipse, sorry. Okay, so you probably can't see this, but now we've got this little circle vibrating. And this vibration diameter or magnitude is so small because it's between -1 and 1. So what we have to do to adjust the magnitude of this wave, we have to, or we can multiplicate this value that is generated here times 300, for example. So now the magnitude of the wave will be between minus 300 and 300. So as you can see, this is much too fast, right? Well, why is that? You know, I was really thinking about how to explain that to you, because that's, from my point of view, it's quite complicated. But there's a very, very quick and easy fix to get rid of that very fast motion here. If we put the frame count into the radians function, the whole thing will get slowed down and it will be a very nice controlled motion. What I can say here is that this phenomena has to do with trigonometry and with the fact that the sine function processing expects a value between 0 and 3.14, which is pi. Well, this is a very complicated topic. I don't want to go too deep into the math and trigonometric functions and calculations. So that's why I just want to tell you that I always use the radians function in combination with the sine function. And you don't have to worry about that anymore and never again. That's it for now. We're pretty far already, because this is the foundation for all the nice things I've shown you in the beginning of the video. And in the next video, we're going to look at cosine, or the cos function, the tan function, map, and well, how we actually can map a value from -1 and 1 to another numerical range. This is going to be pretty much fun. And you will learn a lot about the animations I've made and I showed you in the beginning of the video. And then we are going to put a wave into a loop and see how we can get creative with that setup. So great. Thanks for watching and see you next time in the next video. Peace out. Bye bye.